Hey all, I can see myself. So that means we we are live. We are live, and I hope you guys can hear me well. If you cannot hear me, please respond on the chat. Let me know so I can check it. So assuming you guys can hear us, welcome to today's virtual Muleys meetup. 13 deployment strategies on-prem to CloudHub migration path. It's really a good time to stay online, stay safe wherever you guys are. So just stay safe, right? All right, so let's not waste so much time in there. This is Manik, your usual host of the meetup, and I hope all previous sessions that we had were useful and you guys were able to learn something from it. So that's all good. Today we have someone from MuleSoft's customer success department, and it's Sandeep Deshmukh, and he is going to walk us through the deployment strategies and the migration path from on-prem to Cloud Hub, right? So without wasting like a lot of my talking, I'm gonna hand it over to Sandeep, and he will start with his presentation. A quick reminder: whoever haven't um, joined us for previous one, on right hand side of your YouTube, you should see a chat window where you can keep talking about it, and you can ask your questions, write your questions down there while Sandeep is doing presentation. We will not go to that, but once he's done with it, we will go over all the questions and we'll try to answer as much as we can within the given time. So feel free to write your questions on the chat window right side. All right, with that one, Sandeep, I'm gonna give it to you. Let me change.
Hey, thanks, Manika. Am I audible? Okay, great. Okay, great. Thank you, everyone, for joining today for our online meetup. Today, the topic I'm going to talk about is on-prem to CloudHub migration. And I know this has been asked from a lot of our customers. I've been talking to a lot of customers who are looking to migrate their on-prem applications to CloudHub. So I thought this would be a good topic for every one of us to get an understanding of what kind of effort is involved when you migrate your applications. And if planned well, I've seen a lot of successful migrations for some of the customers that I worked with, and they have been really successful with this. So just to give a quick introduction about myself, right? I joined MuleSoft about a year ago now. I worked in the customer success group of MuleSoft, and I work as a customer success engineer. So part of my role is I make sure that the customer is getting the maximum value out of our platform. I help customers with their strategy related questions or help them with architecture reviews. So I have around like 7+ years of experience. I started as a full stack developer. I was working on Spring Framework, Struts framework when I started my career. Then I moved to working on a content management solution called Tridian. And then I started working with MuleSoft about 2 years ago. So I was working with a MuleSoft customer before. It was an insurance company, and they had bought in MuleSoft, and they were just setting their platform when I joined there. So one of the reasons they bought MuleSoft was they wanted all their external integrations to be done through MuleSoft. So that's where I like help the customer will do their solution architecture, and get really hands-on on the platform. And I've done some implementations for the customer as well. So in the past year, I've done a few of my certifications. I got certifications for the MuleSoft architecture course and the development course as well. So let's move on and get started with our presentation today. So the agenda today is we're gonna get a basic understanding of what an on-prem and a cloud-up deployment model is, and we're gonna understand what are the differences in between them. Then we're gonna talk about why customers are moving towards CloudHub. All the customers are thinking about eventually getting to a cloud-based solution. And next, we are going to talk about what are the actual steps that you would need to think about when you're moving your on-prem applications to CloudHub. And then we're going to end our session with a Q&A. This is a safe harbor statement for you to read. Okay, now starting with the main components of the Anypoint platform, right? So we have our platform divided mostly basically into a management plane and a runtime plane. So management plane is where you are designing your YAML in the design center, then managing your applications using the API manager. And then we have Exchange, which is our most powerful tool, which promotes reusability and makes sure that you're making full use of the platform. And this is where things get tricky, right? The runtime plane. So the runtime plane can is uh, is where you run your actual Mule applications. So runtime plane is the actual VM or the execution environment where the Mule applications are running. So this runtime plane can either be hosted on the customer data centers, it can be hosted in MuleSoft CloudHub and CloudHub deployment model, or it can also, we have also seen customers which have like a hybrid model where they have some applications that are deployed in their on-prem data centers, and they have some applications that are in cloud. And there is another model which is the private cloud, right, where they have management plane as well as the runtime plane deployed in their private data centers. So these are the four models. So we say that the customer is CloudHub only when the runtime plane location is on our Anypoint platform as well as their management plane. So their applications are running on our CloudHub as well as their management plane is on CloudHub as well. Next, we talk about customer hosted, right? In customer hosted data centers, all the Mule applications are running on a customer hosted environment. Customer is basically running a Linux or a Windows machine where they have MuleSoft runtime installed and all the applications are deployed on that runtime. And the management plane still exists in the cloud. So we have like a runtime agent that makes sure that the on-prem applications are able to be discovered in the management plane. And next is the hybrid setup. So in the hybrid setup, we have the runtime plane in the customer data center as well as the cloud app. So customer has few applications that need to be on-prem that are deployed on on-premises as well as cloud app as well. And then private cloud, we have the management plane and the runtime plane both in the customer data center. So why is CloudHub so special, right? CloudHub is our PaaS offering. So we offer CloudHub as a platform as a service, and it is hosted and managed by MuleSoft. In the background, it uses AWS, and it also has uh, multi-tenancy, gives you multi-tenancy for applications. If you're deploying your applications with more than one worker, then it gives you multi-tenancy, and it also gives you more efficiency. As we are using AWS, it delivers up to 99.9% uptime. And the cloud hub environment we are providing to the customers is secure out of the box, right? We are PCI compliant. We have SOC 1, SOC 2 certifications. We are GDPR compliant. So all this compliance are inbuilt in our cloud platform. And next, it also gives you the capability. The cloud hub platform gives you the capabilities to distribute the resources. Like if you have few cores that are assigned to a Anypoint account, it can give you abilities to divide a single core into different business groups or different environments. So that kind of granularity is available when you're using CloudHub. Just looking at the workers, right, under the hood, the way the on-prem workers are structured and the way the cloud workers are structured. This is just for the people who are new to this platform, and I want to give a little bit more insight into how the applications are actually running on the on-prem and cloud workers. So if you see on the left-hand side, we have a VM which is hosted on the customer side, and then We have operating system for on-premises. It can be a Windows operating system. It can be a Linux operating system. And then the customer installs the Java development kit, which can be either 1.8, which I've seen with a lot of customer. Now we have also started supporting Java 11 runtime for our Mule applications. And then the customer installs the Mule runtime, which uses this Java version to run all the Mule applications in that particular runtime. So the way uh, the data center and the management plane is able to communicate with each other is this runtime agent. So the runtime agent makes sure that the connection is established, all your on-prem applications are being discovered in your management plane. That's kind of the on-prem version of it. And next comes the CloudHub, right? In CloudHub, you have it's kind of a black box to you. You don't need to provision a VM. You don't need to have a separate JDK installation. All you need to do is like provision a worker, and the CloudHub will take care of all the things in the background. It will give you a new worker that can run a new Mule runtime instance with a API in it. So the only main difference between this two deployment models is in on-prem, you will have more than one applications that are running in your JVM. While in CloudHub, there is only one application running in a single worker instance. So here are some deployment considerations and the differences that usually make customers think about moving to CloudHub and looking at the differences of it. So one is the infrastructure management. As many of you must have seen that maintaining on-prem servers is kind of usually gets costly, and becomes also a burden for the operations team to maintain all the resources. So what CloudHub platform gives, CloudHub deployment model gives you, MuleSoft maintains all the infrastructure. You don't need to do anything to maintain the infrastructure. It's all taken care by MuleSoft. Next is the isolation. So CloudHub provides isolation out of the box. So each application supports a microservices architecture. So if you're looking to have a microservices architecture, isolation is provided by default in CloudHub. And next we see that on-prem, right? So you don't have any kind of isolation. All the applications are sharing the same runtime. Next is the SLA. SLA for CloudHub is 99.9%. We use AWS in the under the hood, and it's always a reliable platform, no matter what kind of applications we are deploying. And then again, on the customer data center, it's really on the customer on how they want to maintain their on-prem data centers and what kind of uptime they need. So it's all dependent on the customer. And downtime. So CloudHub has another good advantage is we support zero downtime deployments. So if you have a new production release that's going, the customers will not see any impact in their experience. The applications will be redeployed in the background and make sure that there is no downtime for any application. While in on-prem applications, you'll usually see like some minor like downtime when you're deploying a new application. So next is high availability. So we are going to talk about this more in the later slides, but if you want a highly available system in CloudHub, all you need to do is you need to just scale out and deploy it into more than one worker. While on premises, if you want high availability, you have to create server clusters, or you have to create a server group, which will make sure that the application is deployed in one or more servers. Similarly, even load balancing, right? In CloudHub, we have a software appliance that is deployed within your dedicated customer space, which is called a dedicated load balancer that can be used in CloudHub. While on the if you are using on premises, you have to get in your custom load balancer, which can be a F5. And another good advantage of CloudHub is if there is new runtimes that are getting launched, you can always go in CloudHub and make sure that you can upgrade to newer runtime with just few clicks when they are backward compatible. While in on-premises, you'll probably have to work with all the own application owners, make sure that everybody has the visibility, and then you'll have to sync and coordinate when you're doing your upgrades. Uh, One reason that you see when you're working with on-prem or CloudHub is on-prem will have low latency when you're working with your data centers, whereas CloudHub will have a little bit increased latency because using your VPN solution. I may have like interchanged this. Sorry. So why migration, right? I see customers that I work with in the East region for MuleSoft. So they are mostly banking customers, but they are changing the way they are thinking now. More now they are looking for newer solutions that are more cloud based and more efficient the way their company is looking for a forward approach. So one of the most common reasons I've seen is most of the system of records, like most of the customer data of their customers, is stored in cloud now. They're using systems, so software systems like Salesforce. They have Service now. They have Workday. So all that data is already in the cloud. So why would they deploy their applications on data centers? So they are looking for solutions like CloudHub to make sure that their applications are also deployed in cloud. And then another reason I've seen is the upgrade of the runtime, right? Like we just talked about a second ago. So upgrading MuleSoft runtime may be a cumbersome task. Like if there are like 100 of applications deployed on a single on-prem server, then you have to work with those 100 application owners and then coordinate to upgrade that runtime. Whereas in CloudHub, each application can be individually updated, and that gives you the flexibility with the way you're deploying your applications, and also it decreases the dependency. Next is the intelligent healing process. So if you think about on-prem, the on-prem, if there is something goes wrong with your JVM, your entire 100 applications or 50 applications that you have deployed on that server, they go down. Whereas in CloudHub, we have the capability, like if there is something wrong with the JVM, you can select a checkbox in the runtime manager, and then you'll get an automatic restart of that particular runtime. So CloudHub is intelligent enough to find out if something is not responding, and it will do automatic restart for that worker. And again, like we talked about, we have out-of-box support for the microservices. It provides isolation for all the runtime services and make sure that the other service is not impacted. Some services getting a lot of traffic in on-prem, it might affect the performance of other services, whereas this is not the case in CloudHub. It gives you an isolation for each API that is deployed in CloudHub. And again, like just from my personal experience, right? When I was a developer and we had a hybrid deployment model, like getting provisioning a server on-prem was such a cumbersome task. I needed to work with the network team. I needed to work with the infrastructure team to get that server set up. Whereas in CloudHub, all you need to do is just provision the cores for that particular business group or that particular org, and then you can go simply in the org and deploy your application. So infrastructure management is, you don't need to have it anymore. And next is you're actually thinking about innovation when you're thinking about CloudHub. Like you're not wasting time about thinking how to secure your servers, how to do the updates on them servers, but you're actually thinking about the actual business cases that you're going to be focusing on. So let's step in and just understand how you can think about this migration, right? I understand it's a gradual process. I mean, it's usually the best practice I recommend to the customer is go in an incremental fashion. Just don't do big bang, like where you're deploying your entire on-prem applications to CloudHub at once. So what I suggest to them is like go in have a phased approach. In the first phase, you just assess what kind of applications you have on your on-prem. So among those applications, like I would suggest them to like usually select a list of applications that they think is like low risk and can be easier to migrate to CloudHub as a part of their first release. Next is like architecting and setting up the platform, right? Make sure that the architecture for your CloudHub fits in all the security adherence, and then whatever requirements your network team has or your development team has. Make sure that all those are taken into consideration while when you set up your platform. And next is the operation team's readiness. Make sure that someone in your operation team knows enough about CloudHub. If there is there is some issue or something is going on, they can go in and debug those kind of issues. So we have a really good CloudHub operations training. So that's the training we recommend our customers to take before they, start going live with CloudHub or like start actually doing testing for CloudHub applications. So I've seen this effort take around like 12 weeks. Usually customers are ready with the new API development as well as some existing API that they have decided to migrate to CloudHub. And then the actual implementations I've seen take like 4 months. So that's like it can take less or more time depending on what kind of resources you have involved in your effort. But that's like a generic timeline. And then again, like you start deploying your CloudHub application in batches uh, to your CloudHub deployment model. So this is usually the way I would recommend customers to think about the migration effort. Now comes the licensing part. Now everybody has to just have a basic understanding that one on-prem core is equal to one vCore in CloudHub. So it means the same. So the migration, if you're thinking about doing it in a phased approach, you'll require some licenses on-prem and some licenses on CloudHub. So that will require like a hybrid deployment model for you and for that as a temporary solution. And then it is also possible to convert your existing on-prem cores to CloudHub cores. So our customer success team can help you get that sorted out. Just work with their MuleSoft counterpart, and they can help you understand the problem and then also give you some recommendation on what would be the best cores. You can either get new cores for your cloud effort or use the existing cores. Now comes the actual platform setup. Once you know that you have made a decision to move to CloudHub, then comes the part where you actually need to do the work and set up your platform to make sure that it's compliant with all the requirements that you have. So one of the tasks that you usually will end up doing if you're on-prem customer is set up a VPC. So VPC in CloudHub is like an isolated network that is assigned to your customer account. And in that isolated AWS network, you can deploy your applications in that VPC. While we also have, if you don't create a VPC, right, we have like a shared VPC. If you don't decide to create a VPC, all your applications will be deployed in the shared worker cloud. This shared worker cloud is shared by all of our customers, and your application will be shared with the other applications of the other customers. So like I mentioned, the VPC, we have the AWS cloud. Inside that, we have our MuleSoft Cloud Hub. Inside that, we have your VPCs. In the VPC, if you have decided to go with a dedicated load balancer, even in load balancers, we have two types of load balancers. One is the shared load balancer, and then we have the dedicated load balancer. Dedicated load balancer comes with like more capabilities, which we can talk about in the later slides. But that's kind of the model if you're creating a VPC. So if you have a dedicated load balancer, it will always sit within your VPC. And the most common uh, setup that I've seen with customers is they have like a production VPC and a non-production VPC. So all your non-production applications will be deployed in the non-production VPC, may be your QA, dev, or staging. And then you will have like a separate VPC, which that will just have production setup and all the applications related to production. Now, how would you provision a VPC? So VPC, I just explained you what a VPC means and how it is used in a CloudHub setup. But then also there is a lot of things that you need to be careful when you're setting up your VPC. So when you're creating your VPC, so try to create it at the master org level. So you have the, if you know a little bit about access management, so you can have different business groups in any point organization. So if you decide to create a VPC, I would say like create it at the topmost level. And when you're sizing your VPC, think about like future 2 to 3 years on what kind of implementations are going to be done in with MuleSoft, and size the VPC accordingly. This is because once you size the VPC, it's not easy to like go back and change the size of that VPC. So usually the rule of thumb is make sure that you have, if you are deploying 40 applications in couple of years in the Mule production, then make sure that it at least the VPC size has at least 400 IP addresses. So we have different CIDR blocks. It can range from /21, 22, 23 to like the biggest CIDR block that we have is /16. So make sure that you have at least enough IP addresses when you're sizing your VPC. And when you're creating a VPC, another thing is you need to select a region. So if you have your data centers, for in most of my customer cases, like they have their data centers nearby North Virginia, so they decide to create their VPC in North Virginia. So that's like the closest to their data center, which minimizes the latency. So that's another thing you need to think about. Again, like I told you, right? When you're creating a VPC, what is the best practice? Usually, is the example 3, where you create your VPC in the master org level, and the VPC can be shared with business group A, business group B. While there is other VPC pitfalls, right? Where if the VPC was built with a business group B, it can only be shared with the child business groups of that group B. It cannot be shared with any other parent group. So it's very important when you're deciding that you're moving your applications to CloudHub, decide the VPC where it will reside, and then also decide like future 3 years of what kind of applications will be there. So this is a common pitfall that I've seen with customers. They just need they don't have understanding in the initial stages, and then we end up like having a mess of all these applications. Once you have configured your VPC, then you actually need to think about how your north-south traffic is coming, how the traffic is coming from internet, and how east-west traffic is flowing. So first, connecting network consideration is how your traffic be managed when it comes from the internet. So one option that you have is having your Mule application in a shared worker cloud. So all all the applications will be deployed on your shared worker, and the traffic will be coming to the cloudhub.io URL. Since you're using the shared load balancer in this case, the URL will always have the cloudhub.io in the URL. And the CloudHub shared load balancer always listens to 80E1 and 8082 port for HTTP and HTTPS communication. And then internally, the shared load balancer will send the traffic to the Mule workers, which will eventually reach to the actual Mule implementation app. So there is another way you can, if you don't want to use a shared load balancer, you can also send the traffic directly to the Mule worker if it's listening to the 8081 and 8082 port. But then in this case, you're not getting the functionality of actual load balancer, but it's doing DNS load balancing. So another implementation that we talked about, like creating an actual private VPC for your CloudHub implementation apps. So here on the left side, if you see, there is 2 VPCs that have been created for customer, and the Mule applications have been deployed in those VPCs. And the traffic is coming. In this case, we are still using a shared load balancer. And when the traffic flows through the shared load balancer, it navigates to the private VPC. So VPC also has the capabilities to add firewall rules. Suppose you don't want uh, traffic from a certain IP range, you can just whitelist that IP range in a VPC. And another firewall rule you can add is if you don't want any other ports being accessible through VPC, you can just block all the other ports other than 8081 or 8082. So those kind of firewall rules can be applied, and this gives you like an additional layer of security to make sure that everything is secured in the VPC that you're deploying to. And another is once you have deployed all your applications in CloudHub VPC, you also need a way to connect it to your data center. So we have different options that we can talk about in the later stage, but usually we support IPsec, AWS peering if you're peering with your AWS data center. Then we have direct connect, which is like a faster way to communicate with your data centers. So we support all three and some more. Now, next comes the dedicated load balancer. So what are the scenarios you would use a dedicated load balancer for? Suppose you want a proxy URL where you want, whenever a customer or a client application interacts with your Mule application, you want your company domain to be in the URL. At that time, you recommend that the customer deploys a dedicated load balancer, which gives them the capability to have custom domains. So what it internally does is the load balancer will create a vanity URL on top of this URL, and it will send all the traffic to the load balancer. So in load balancer, if you want to make sure that your internal MuleSoft implementation apps uh, are not exposed over internet, so what you can do is you can only deploy your applications with 8091 and 8092 ports. These are the private ports in CloudHub, and all the traffic or if you block if you're using 8091 and 8092, all the traffic will be within the VPC, and if you want any external traffic, it only has to come through the dedicated load balancer. So this is kind of the flow if you're using dedicated. So you can also have like a combination. If you decide you don't want to use a dedicated load balancer, you can also have a shared load balancer. Now comes the part where you're actually establishing the connectivity. You have all your CloudHub applications that are deployed in your VPC, but now you want to make sure that the connectivity is available to your data center. So like I talked about, right, you can have IPsec tunnel setup with your data center. Then we have, if you have a AWS 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 account where you want to pair your AWS VPC with the MuleSoft VPC, we offer AWS peering. And we also have a direct connect. Uh, just whatever suits your needs, we can help with that. And the VPN setup with CloudHub is like a self-serve process. It does not cost you anything. With the best subscription, we give like four entitlements of VPN. So you can always have up to 4 VPN connections to a VPC, and make sure that all the data is securely transferred between your CloudHub VPC to your on-prem data centers. So if you have set up your VPN, right? But next thing you want to check is usually if the connection is properly set up. So what we have done is like we have created a Mule application. What you can do is just deploy that application to your VPC on CloudHub, and then just ping one of your on-prem data centers and see if the connectivity is established. This is usually the recommended way. I ask the customers to check the connectivity is established before they actually start development of applications to be deployed in CloudHub. So now comes the part where all the developers must be curious. What are the application code changes that you need to do to make sure that the on-prem application is working in CloudHub? So the biggest change, I think, for me when I was doing my migration of projects was changing the domain project. So domain project concept is not supported in CloudHub. So if you're using shared resources such as database connections or your HTTP configurations, all those need to be segregated for each applications in the CloudHub. So that's one of the major change that you will need to do when you're migrating your on-prem applications to CloudHub. Next is the ports, right? The CloudHub listens to 8081 and 8092 port uh, when you're using a shared load balancer or you want to expose the applications to the internet. And there is also a way for you to make sure that the access is not external by using the 8091 and 8092 port. And I've also found that we had a few scenarios where we had reusable code. So we had code snippets like error handling and all that that were maintained in our domain application. So what we had to do was like basically create a jar, which was so what you can do is like create a jar, put out all that error handling or the common code snippets that you need for each CloudHub application, then import that jar as a dependency in every CloudHub app. So that will make sure that you don't have to write the same code again and again in every CloudHub application. Another thing I noticed is there's not a lot of changes that you need to do with your data weave. Most of the data weave code works as is, but in some cases you will need to do some minor changes. Next is the environment properties. Suppose I'll just give you an example of secure properties, right? In on-prem applications, if you are using secure properties tool, then usually the key would be residing somewhere on the on-prem JVM arguments or wrapper configuration or somewhere like that. But in CloudHub, what you need to do is basically move all those properties maybe in the runtime manager properties tab, or like have it done through the CI/CD, because you won't have the capability to go into the CloudHub worker and add those arguments. So all that needs to be changed when you're doing your CloudHub implementation. The next thing is the on-premises server, right? So if you're using an on-premises Windows machine, so the way you would have logged in before was basically had like a Windows authentication to log into your system and make changes. But in CloudHub, the only way you can access your CloudHub is you need to log in through your AnyPoint account. Like you need to, if you have a SSO, if you have an IDP enabled for any identity management, then you need to log in through that and make changes to your CloudHub workers. So that's another change that will happen when you're using CloudHub. Another thing is, suppose you're connecting your Mule applications in on-prem with your Windows systems, like some like MS Dynamics or PowerShell. What you'll need to do when you move to CloudHub is you'll need to make sure that you install a Windows Gateway service on your MS Dynamics server to help the connection from CloudHub to your MS Dynamics systems. So that's another change that you'll need to do. Then again, like when you're actually doing the migrations, think about redesign. Like there's so many things that you can do in CloudHub. You can improvise your design. You can use the object store v2 connector because that's not supported in on-prem. So think about all those capabilities that you can implement when you're moving to CloudHub that you were not able to do when you're on-prem. Another is the SFTP connector, right? A file connector gets replaced with the SFTP connector when you move to CloudHub. So this is a kind of the generic idea of what the development changes that you need to do with your Mule applications. Now comes the CI/CD process. So when you were having your on-prem systems, you probably had a CI/CD setup, but you will also need to create a new CI/CD or probably make changes to the existing CI/CD to accommodate the CloudHub deployment. If you are using the platform APIs, which help you to deploy application like a jar from your CI/CD to the runtime manager. So those APIs will be different in CloudHub. So CloudHub has its own set of APIs to help you with the deployment. And then we also have, if you are using Anypoint CLI for your CI/CD, then the CLI commands will change. So you need to think about changing all those commands and making sure you're using the right APIs when you're doing your CloudHub deployment. Next comes the monitoring and logging part of CloudHub applications. So if you were using on-premises solution, uh, you probably had some kind of some way to get logs or like send it to your external systems like Splunk or Elk. CloudHub does it in a different way. First of all, CloudHub stores only 100 MB per application and per worker for 30 days. So if you have logs that are going to go beyond 100 MB, we strongly recommend that you implement sending the logs to an external solution, which we have the capability to do in CloudHub. There are good documentation on our website which can help you with that. But if you don't want to send it to an external system, we also have the Anypoint monitoring feature, which allows you to store the data beyond 100 MB. It actually gives you 200 GB storage per production core, and you can store the data for however time you want. Next is the external external logging systems, right? I just talked about. So if you're not able to integrate your Splunk or Elk, we also have the ability for you to download those logs. So we have the CLI commands. We also have a CloudHub API that will help you download the logs, store it in your database or your external logging system, and make sure that you never lose any logging if you need it for your production or any kind of deployments. And then comes the alerts. So I don't know how many of you have implemented alerts, but it's one of the features that is offered in the base subscription. So if you have any alerts set up for your on-prem application, make sure that you also set up the same similar alerts for your CloudHub applications. You'll have to go back into the platform and make sure that you add the alerts that are related to CloudHub. Then another one of the best features of CloudHub, right? So it's the auto scaling policy. So this is something that is not available in on-prem. So auto scaling is only available for our enterprise license agreement customers. Uh, what it helps you do is you can auto scale your Mule applications. If there is a high usage of CPU, you can make sure that you set a policy which will increase the number of workers or decrease the number of workers. So auto scaling helps you in that way. So, so how do you do scaling in on-premises? What you usually end up doing is you usually add RAM or add a heap memory or add more cores to your on-prem servers. So that's the only way you can scale your on-premises systems. And also load balancing is done outside Mule. But if you're doing CloudHub deployment, the scaling can be done basically if you want to scale up, you can increase the worker size from zero point 0.1 to whatever vCores that you think, and then you can also scale out. You can actually select number of workers that you want to deploy the CloudHub application to. So another feature I talked about is auto scaling. If you have a ELA agreement with MuleSoft, we let you auto scale the workers up and down depending upon the memory and CPU usage. Now, every implementation or every company has its own guidelines on how to make sure that the applications are highly available and disaster recovery is in place when they are doing their deployments. So the way CloudHub helps you achieve high availability is if you are deploying a cloud application in more than one worker, then it will deploy in different availability zones for that region and make sure that your Mule applications are highly available. So availability zones are a part of Amazon functionality. Basically, they are the requirement is they must be located 60 miles apart at least. So if there is some disaster happening in one of the availability zone, you are still protected with the other availability zone. So that's how you would do high availability. So some companies, I've seen some financial institutions, they have a requirement to also have a disaster recovery in place. So in disaster recovery scenarios, what you can do is you can deploy one Mule application in the Amazon East region, and then you can deploy another Mule application in Amazon West region. So in that case, what you do need to do is make sure you have like another external load balancer that will take care of balancing the load in case one of the region goes down. So that's how you would approach the disaster recovery scenario. So one of the very important step that just doing a time check at 15 minutes. Hey Manik, sorry. Uh, Next is the performance testing. So yeah, I think I'm almost done. So let's try to get through this side because this is one of the important part I don't want to miss on. So when you have completed your deployment and development, and you have deployed all these applications to CloudHub, you also need to think about doing performance testing. So performance testing is going to be very different from your on-prem application. In on-prem, you had all this CPU that was shared among 100 applications. Then you had a huge RAM. But in CloudHub, since it is divided into workers, each worker has its own capacity, the way they can handle load. So you need to make sure that you're replicating the production loads when you're moving to CloudHub. And I'm going to talk about a bursting feature that most of our customers don't know much about, and they forget to take it into account when they're doing performance testing. So the way our worker sizes are divided is if you the smallest worker size that is available for you to use is a zero point 0.1 vCore. So zero point 0.1 vCore gives you a usable 500 MB of heap memory, and it gives you 1 GB of RAM as well. And the instance in the background that we spin up in AWS is a T3 micro, while for zero point 0.2 vCore we have a T3 small. So usually we'll have two CPUs. So that's something that most of our customers don't know, that the AWS has two CPUs, and sometimes they see better performance in CloudHub. And it's just not fair to compare on-prem one core performance to CloudHub. So I get a lot of questions around that. It's just the architecture is different, and there's a lot of factors to consider when you're doing performance benchmarking. And one thing to notice here is the fractional vCores, right? Point 0.1 and point 0.2, they have the bursting capability. So if you are doing if you're doing performance test on point 0.1 and point 0.2, what you can see is usually a really good performance in the first couple of hours, but then again it starts degrading. That's because we have the bursting capability. So what is bursting is basically all the credits are earned at a constant rate for a particular worker. So these credits are basically for you to like go beyond the CPU capability of that worker, and it can run up to 100% for a specific number of time. So that's how you would categorize bursting. And again, like one CPU credit is 100% utilization for 1 minute. And then again, there is a lot of calculation that happens, but just to give you a small answer to that, is that we have bursting capabilities that gives you better performance for a shorter period of time, and then it goes back to normal processing. So, and if you're not using the bursting capability, it will get accrued till you actually use that CPU credit. So if you have an application that only has processes for a small amount of small time in a day, then usually like point 0.1, point 0.2 worker will be enough to do that kind of processing. One CPU. So one CPU credit is equal to one CPU running for 100% of the time. So next comes the security, right? If you have so CloudHub out of the box gives you a secured platform to make sure that all your applications are secured. It makes sure that each application that you're deploying is has its own virtual machine, and the payload that is being sent through that application is not being visible for by any other application in that VPC as well. And all the communication that is happening between the CloudHub and the management, everything happens via HTTPS. Everything is secured by TLS and SSL communication. Next is the compliances. Like I mentioned in the starting of this meeting, our platform is PCI certified. We have SOC 1, SOC 2 certification. Then we are high trust certified. So all the certifications are out of the box. So you don't really need to be worried about if you have like PII data that's going in and out and all that kind of things. And even if you have some credentials like username, passwords, we never store them on our platform. Everything is stored in a S3 bucket in an encrypted fashion. So nothing ever is going to be available for us to use. And again, like CloudHub platform gives you capabilities to deploy in different regions in the world. So you have the multi-tenancy and all those capabilities that come in out of the box. Another thing is if you have API security, right? If you have policies that you have applied to your on-prem applications, or you have client applications which have contracts established. So when you move to CloudHub, I think you'll probably need to renew those contracts. You'll need to uh, send the client applications again need to request access to your application and do that process. So make sure that you take into that into account as well. I did not mention in the slides here, but that's something that you need to keep in mind. Yep, I think that's about it. I think we pretty much covered all the things that you will need to plan out when you're doing your migration. But let's take some questions now. Hey, Manika, I'm ready for questions. Yeah, I can hear you. Mhm. Yes, so you can definitely automate your deployments. So if you have Jenkins, what you can do is basically build your mule applications, build the jar, and then in your CI/CD process, you can either leverage the CloudHub platform APIs that let you deploy to the runtime manager directly without ever interacting with the console, or you can either use Anypoint CLI. So depending on what you're comfortable with, you can use either you want Mule Maven plugin or platform API or Anypoint CLI. Yes. So the question was, is the hybrid model available? So can we have like a hybrid deployment model? Yes, it's absolutely possible. You can have your on-prem service registered to the platform as well as CloudHub cores. So you can have some applications that are deployed on on-prem as well as some applications on CloudHub. So there's the server section that helps you register a server in a particular business group and an environment. And vCodes are assigned for a business group when you create a business group. So both can be done in parallel. Yeah, no worries. Yeah, so the question was around the zero downtime deployment. So what CloudHub does is it spins a background and deploys the new jar that you are deploying to the new worker. And until that new worker is ready, it does not switch to the new worker. So all this uh, switching happens in the background. So the user or the consumer is never really affected when the new application is deployed. So that's how we take care of the zero downtime deployment.
Okay, that's good one. And what's the best approach to migrate domain applications from on-prem to CH, Cloud App?
So, like I mentioned, domain applications are not supported in CloudHub. So the question was, sorry about that. The question was, how can we migrate domain projects to CloudHub? So CloudHub does not support the concept of domain projects. So that's the reason being the each mule implementation is deployed in its own VM. So there is no way it can share the information from another VM. So what you will need to do is segregate all those resources and have each application a separate implementation of HTTP listener database configuration. And one thing I talked about in my slides is if you have some code that needs to be reused in every application, suppose error handling or like some configurations, package it into a jar, and then every new cloud app application that you create, add that jar as a Maven dependency. So you're still kind of having that reuse capability, but not to the same extent as the domain application.
Okay, thanks. So, given Cloud Hub is recommended, what are some limitations with that approach versus on-prem?
So right off the top of my head, so the question was, what are the limitations of Cloud App when you compare it with on-prem? So I mean, the the advantages outweigh the disadvantages, but right on the top of my head, some customers have requirements where they need more application density. So in on-prem, you can deploy on one core up to any number of applications, right? Till it breaks. Like you can have 50 applications in a one core machine. While in CloudHub, the minimum you can deploy on CloudHub is zero point 0.1 vcode. So the maximum you can have in one core is like 10 applications in CloudHub. So that's one of the primary reasons most of our customers move to on-prem and later on regret doing that decision and come to CloudHub again because there's so many better things to do in CloudHub. And other thing, I mean, maybe network latency, right? CloudHub, you're deploying it in a separate VPC. It's not similar to what you're deploying in your data center. So maybe a little bit latency when you're communicating to your uh, on-prem application.
Okay, thanks. Uh, so, if we have more apps implemented with batch processing mechanism, is it advisable to go for Cloud Hub from on-prem? Hey, just FYI, my voice is now going on the stream, so you don't have to repeat the question. Sorry about that.
Oh, okay, great.
Yeah.
So from my experience, it really depends, right? If that batch is going to be batch processes recurring throughout the day, then in those scenarios I would rather deploy that application in the cloud hub because it needs constant processing power. But if there is something that is only going to occur once in a day during, uh, like office after office hours or something, which does require processing power, but just for a smaller amount of time, then I would think about deploying it in on-prem and having that large processing power for different scenarios. So there's different things to consider, but this is like one of the common things I could consider.
Okay, thanks. One question is, I think you mentioned each Mule application deployed on CloudHub has its own JVM, right?
Yes,
Opposed to multiple apps in there. So that's correct, right? It just I think it's just a confirmation that understanding is correct. So it's
yes,
correct.
that is correct. Each application will have its own OS, own JVM. MuleSoft will take care of it under the hood. The customers don't get the So customers they don't have the access to those workers. So all the JVM arguments will be set to default. You can't really make a lot of changes on those workers. And all of the settings are done. All are optimal settings. You never really need to do any changes to those workers.
Okay, thanks. So one question here is which deployment model is more efficient for enterprises that use other middleware products and willing to switch to MuleSoft? What criteria should we consider in choosing deployment model?
So the criteria will be what is the most important thing, right? If you if if you don't want to maintain infrastructure, then I would suggest to go with CloudHub. It also depends on what kind of use cases you have. So if you have use cases where there's only, I don't know, one call per day for that particular API, I mean, I would deploy that API to on-prem, like if it's just going to be called once in a day. Or I mean, there's so many things to consider, right? If you need zero downtime, but I always recommend customers to go with CloudHub approach. It has the latest and greatest features. It gives you so much more. Anything that is newly introduced to the platform come first to the CloudHub. So CloudHub is the way to go, I would say.
Okay, thanks. I think we are at the top of the hour, but let's see if we can take. There are only few left. So, are there any SSL certificate issues to be aware of if we are using it? I hope it's for the cloud app.
So I've not seen not really, right? I mean, the runtime agent takes care of all the certification and the communication between your CloudHub and the management plane, and it all happens in the background. So one thing that you need to make sure is that there is a list of IPs and ports that are on our Mule documentation site. All
Mhm.
those are being whitelisted or the ports are opened up to make sure that there is no complications with opening any application or port in that case.
Okay. Probably last two questions. Does the CloudHub API require Mule applications to be packaged as a jar for deployment? I think that is for anything for Mule 4, right? Mule 4 applications are jar.
Yeah. So yeah, Mule 3 are packaged as zip, Mule 4 are packaged as jars mostly.
Okay. Uh, as per Ravi Kumar says, as per my knowledge, in Mule 4, even if we have on premise, we need Cloud Hub deployment first. Why this kind of dependency? I'm not sure. Is that how? I don't.
Uh, Not really. I mean,
Yeah.
I'm really confused with that question.
No, I mean, as far as I know, even there is no such dependency. If you are purely on premise, you are on premise. You have no reason to require Cloud Hub, right? There is no like dependency that you must have Cloud Hub first, right?
So I think he's talking about the hybrid model, right, where the
Mhm.
management plane is in cloud
Okay.
and the server. So in that case, you would just need access to the runtime manager. So our runtime manager is running in CloudHub. So that's the
Mhm.
only dependency you would have in those cases.
Okay, so it's like you are using the management plane of the
Right,
platform, not actually the Cloud Hub deployment model. Like
right.
you are not
So
deploying on the.
right, exactly. That's correct.
Okay, okay, that makes sense. Okay, so how many apps is recommended to be deployed per runtime in an on-prem setup? I think this could be the last question.
So it really depends on the traffic, what kind of processing is done in those flows. But my recommendation to customer is don't go beyond 20 to 25.
Mhm.
It gets really messy when you see performance issues to track which application is causing problems. Then again, there is noisy neighbor problem if some application is using more
Yes.
resources. There is a lot of complications that happen if you go beyond 25. I
Yeah.
mean,
And
Manik, you can, yeah, echo, right?
yeah, and no, I definitely and I think one of the difference between Mule 3 and Mule 4 is also how the threads are shared, thread groups are shared. Like with
Right.
Mule 4, there is only one thread group now, and it's being shared across the runtime. Versus in Mule 3, you was able to have a different thread pools per application basis and not to intervene with each other. So yeah, I mean, it really depends how is your activity in the apps on premise, and it will differ from use case to use case.
Mhm.
Yeah. Okay, I think we are 5 minutes more. Let's see. Do you have 2 minutes to take one or two questions?
Yeah, I can take another question.
Okay, so this is done. So Naresh, is CloudHub 100% reliable all the time? That's a tricky question.
so so we do. I mean, there is. Yes, it is. I would say it is reliable. We do guarantee 99.9% availability. The only cases, some of the recent scenarios is where our runtime manager was not accessible for few minutes. So we see those kind of cases, but your applications never really get affected. So I would say it's really reliable.
Okay, so it's like the management plane was not
Mm,
accessible, not there.
yeah,
Like them was still running, applications were executing as they
right.
should. Okay,
And you get those kind of reports on our Mule website. So we have those kind of reports as published on Salesforce page or MuleSoft documentation. You can always reach out to your MuleSoft counterpart and get those kind of reports of the downtimes and all that.
okay. I think one. I only see one last. So Manish says if I deploy one application in one worker in VPC, how many IP addresses got assigned to the particular application?
So if you deploy to one worker, only one IP address will be assigned. So there is the calculation for that. So if you have non-production environment, right, non-production VPC, and you have three different environments. So if you deploy the same application in dev, QA, and staging, then it will take three IP addresses. But if you're deploying in one environment and one application, only one IP address is allocated.
Okay, that's cool. Thanks. Uh, do we have statistics for identifying core size for TPS? It's a very subjective question.
Yeah, it's 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 so our MuleSoft team, if you have use cases that you need help on understanding how to size an application, reach out to your MuleSoft account team. They have a way to help you size those applications, and we have some benchmarks that the team can help with. I don't think they are published on the internet, but since it has a lot of factors to be considered, it's very difficult to estimate it right off top of your head.
Yeah. All right. One last question now, and it is actually the last question on the chat too. Justin says one of my client in New Zealand is worried about latency. How should we address that? Like latency, usually, how would you go after latency issues in the application?
So I mean, the latency for what, right? Is it the latency from your internet to cloud hub application? Are you talking about latency from your implementation to your data center? So if it's like from your VPC to data center, then use better ways to connect, right? Direct connect is a good option when you want faster communication to your data centers. So there's different ways you can handle that with if you have a specific issue, then maybe we can try to address that.
Okay. I think that should be it because we are 9 minutes over. I know lastly Manish said I think three IP addresses, two private IP and one public IP addresses. But yeah, is that true?
No, I can get back to you on that, but
Okay.
from my knowledge, yeah, it's one public and one private.
Okay. That's fine. So I think we are 9 over, so we can take break here now. So thank you very much, Sandeep, for extra time and walking us over all this presentation. It was really good and helpful. And thanks for taking the questions also.
All right, great. Thank you, Manik. Thanks for the opportunity. This was fun.
No, thank you. And thank you very much, everyone, for joining us tonight, today, afternoon, morning, whatever it is at your place. Just to remind, you might receive a feedback email after this one. Feel free to submit that and let us know what helped, what did not help, or what you want in the future sessions. It will help us to schedule more events for it. So until next time, thank you. Have a good night, good day, and stay safe again. Okay. Thanks, everyone. Bye.
Thank
Thanks.
you. Stay safe, guys. Bye.
Bye.